and welcome to Winter Hall in Santa Barbara. This is CS-030. Let's see if we can fire this up. Oops, that's not really running well. All right, let's see. Overhead screen. I'm on camera. I've got a big. Welcome to Monday morning. It is chilly afternoon in Santa Barbara. We're broadcasting live from Santa Barbara, California. Westmont College's Mayterm class. This is CS-030. 5-week class. Today's lecture is scheduled for 2 hours. We are continuing on chapter 3 today, location classes. And communicating in real time on Slack. I've got Slack up down here on my panel in front of me if anyone remotely is interested in checking in. I think with that, we're ready to go. Let's just take a second and arrive. I've been doing this all morning, trying to arrive. Make sure our notifications are off and our cell phones are shut down and whatever we want to turn off for notifications is turned off. And I think since it's the start of the week, I'll just read off the prayer, or offer the prayer that we did last week at the beginning of class. Good to just remind ourselves of the bigger picture of what we're doing. So with that, Lord, grant us to greet the coming week in peace. Help us in all things to rely upon your holy will. In every hour of the day, reveal your will to us. Bless our dealings with all who surround us. Teach us to treat all that comes to us throughout the week with peace of soul and with firm conviction that your will governs all. All our deeds and words guide our thoughts and feelings. Unforeseen events, let us not forget that all are redeemed by you. Teach us to act firmly and wisely without embittering and embarrassing others. Give us strength to bear the fatigue of the coming week with all that it shall bring. Direct our will. Teach us to pray, and you yourself pray in us. The glory of the Father, and of the Son, and of the Holy Spirit, now and ever, and unto ages of ages. Thanks. All right, administratively, you guys should have completed a quiz on Chapter 1 last week. We have a quiz on Chapter 2 due this evening, and on Friday there's a quiz for Chapter 3 as well. There's a programming assignment for Chapter 3 due on Friday. It's the implementation of our letter class. We talked about that briefly at the end of last week. This week, the plan is what we're going to be covering is Chapter 3 today, Chapter 5 for Tuesday and Wednesday's lecture, Chapter 6 for Thursday, and Chapter 15 for Friday. So we're blowing through it very quickly. There'll be some quizzes to help you get through the reading on that as well. Usually in CS-030, we would also cover Chapter 4. I'm trying a little bit of a different approach, and I'm going to just skip over Chapter 4. Chapter 4 talks about fundamental data types, or data types that aren't objects, and they are legacies from the C ancestry of the Java language. They're used pretty often, but because they're a slightly different paradigm and because time is short, we're going to just focus on objects and object references. If you ever encounter things like double with a lowercase d, or integer that's just lowercase int, a couple other lowercase variable types, that's what these are. They're primitive data types. And you can use them as well, but if you read that chapter, I think it's pretty straightforward. It just talks about those kinds of variables and things like how to do arithmetic on them, etc. And that almost all of the syntax for arithmetic that's non-functional, meaning just symbolic, like the times, the star operator, the minus, the plus, those are all the same as Python. So it should be sufficient to go through Chapter 4. I'm not going to evaluate you on it. Pretty straightforward. All right, last time in class, what we did is we implemented 2 classes. We implemented a clicker class and a bank account class. And the purpose of that was to help you guys see the syntax for doing object-oriented programming in Java. Also to get a sense for what it's like to design a class. Of course, Java uses classes as first-class citizens, meaning everything in Java is an object. And so constructing objects is like bread and butter for programming in Java. And quite frankly, it's pretty common just to be the base organization for most programming languages nowadays. Although you don't always realize you're working with objects sometimes. You're just using methods and maybe not thinking about it. So we worked with those classes and we set up some testing for those classes using JUnit testing. So today what I'd like to do is I'd like to dig into some of that again. I'd like to look at the design, how to design some of those classes. What is the design process you go through when making an object? And then finally look at JUnit testing in some more detail to fill that out a little bit. We did it, but we didn't want to talk about it. Sound good? So the design of a class. So before a class can be implemented, as a systems programmer, you implement a class. That means you write the code that does the work for it. Before you can implement it, it has to be designed. And that process of design is going through and thinking about the behavior of the class. And particularly, you're thinking about the behavior and how it's going to be used. So how the application programmers are going to use the class that you are making. Even if you're going to be the application programmer, during the design process, you think about how do you want other people to use it in a programming context. So what does that mean? Well, you think about what is the idea you're trying to capture with this class? What sort of tool is it going to be? Is it going to be representing a physical object, car? Is it going to be representing some ethereal object like a bank account? Is it going to be completely abstract like the internet request? Something like that. And once you decide what you're actually going to do, you think, well, what are the methods that applications programmers are going to call on this object? What are the ways in which they're going to interact to try and achieve some kind of functionality? And which order are they going to call things in? Are we going to somehow enforce that? Are we going to call methods multiple times? How's all that going to work? Now, clearly, there's going to be a constructor. The constructor is always the first method that gets called. And so the design of a constructor is primarily about how do you want to initialize this object? Do you want to request the users to pass parameters in as part of the initialization process? Or do you want to just have no parameters? You initialize an object, and then if you want to change it in the future, you have to call some set parameter one, set. So that design process, we went through. We did it really quickly and maybe implicitly in the process of creating the clicker class and the bank account. But if the question is what methods are we going to need to implement, well, in the clicker class, we worked through some. We knew that or at least I told you, we didn't actually design it. We wanted a reset. That was going to set our clicker back to 0. Again, a clicker is something that keeps track of the clicker class was supposed to represent one of these physical objects that maybe an attendance counter clicks on with their thumb as people walk through a turnstile or a parking lot. So reset would be the equivalent of setting that thing to 0. Click would be the equivalent of clicking it one time, incrementing our count. Unclick we made up on the fly. That's actually not in our textbook. We decided to do that in class. And unclick, and I don't actually know if unclick is something that you can usually do on one of these clickers, but we said we're going to allow it to happen. We're going to roll back our number by 1. And then lastly, we're going to have this get value method because our object itself doesn't have any kind of display. We need to know what our value is and current attendance is. So we call it get. So these are the methods that we ended up designing to be implemented. Bank account had a similar set. Again, both of these are ignoring the constructor. But we knew that we wanted to deposit money and withdraw some money, get the balance. We thought a little bit about why we might want to do that, and how that might actually get utilized. Once you've got that, you need to think through, okay, you've got these methods, you have this behavior. Which one of these methods are going to have side effects, and which ones are going to have return values? So the side effects might be outputting something to the console. If we have more structure, we might say that's going to send something out through the internet. Maybe the side effect is going to change the instance variable inside the class. So there's all different ways in which a method can have a side effect. It can also have a return value. Maybe the reason we're calling it is to get some value back. And maybe it's both. So we ran into a situation when we were designing our bank account class where we wanted to withdraw some money. And it kind of seemed like it was natural that our withdraw method should both withdraw money from our balance, meaning it was going to have the side effect of lowering our balance. But we also thought, hey, it might be nice if it actually returned the amount that was withdrawn. And in our initial design, we didn't have that. So if we did return the amount that was withdrawn, then it would have both a side effect and a return value. There's no reason why a method can't have both of these. All of these, though, are design decisions. So they're not something that have a clearly correct answer. They're really driven by how you expect programmers to use them. And so that thinking about how programmers are going to use them dictates what the correct answer is. And even though there might not be a correct answer, there can certainly be a wrong answer, in that you can have bad designs even if there isn't an ideal perfect design. Once you have that behavior, and once you have the methods designed, then you can go ahead and stub out the class. And by stubbing out the class, what I mean is that you start to do the implementation. You have, up to this point, you've just thought about it conceptually, maybe jotted down some notes, maybe put something on a whiteboard or post-it notes. But now what we're talking about is we're talking about actually starting to write some code. So this is an example of a stubbed out class of our bank account class, presuming that we had already gone through the design process. So what can you see here? Well, you can see there's a lot of to-do lines. There's a lot of comment lines. You can see I put a comment in front of the class and then in front of each one of the methods. And you can see I'm using the JavaDoc style comments. You can see that I have a single line comment, many of them, which say to-do on them. And the to-do indicates that there's something to be done, obviously. But the thing about using that syntax, a capital TODO, is that Eclipse will process that and give you one of the views as a little list of check marks of all the things that you have listed to do in your code. If you open Eclipse, you can see all the list of the to-dos as well. That's a good way of reminding yourself to come back. The other thing here is that we've specified the names of our methods, we've specified all the constructors, we've specified the return types, and in the case of getBalance on the bottom right, hopefully I'm not in the way there, you can see that we had to specify a return value. We just said return null, not because we want that method to return null, but because we need it to be able to compile. And unless we actually put return something in a method that needs to return something, this stub won't compile it. Now we do this so that we start working through the process of making sure that what we're going to start implementing, once we get down in the weeds, is really driven by a design that makes sense. So we can stub this out. What's interesting about stubbing something out in this way is you can immediately generate JavaDoc for it. So you don't need to do an implementation in order to create the JavaDoc. Last time we looked at JavaDoc, it was a setting under the top of Eclipse, and we could drop down and generate the JavaDoc, and it created a website that was within our project. We could open one of the pages, and this is an example of what would get generated from the JavaDoc process. And what happens here is that you can see all the constructors and all the methods that are public, because JavaDoc is really designed to be consumed by application programmers, people who want to use your class. So because of that, you don't need to implement anything. You can just put all the JavaDocs in there, and you've got it ready to go. And you can make that, and you can say, well, is this how I want to present my object to the world? Is this what we want to do? And it makes a lot of sense to make sure you're doing the right thing before you spend a lot of time implementing all the details. In fact, this style of development is so compelling that it actually has its own name. If you go on to write tests for it before you actually do the implementation, it's called test-driven design. We'll look at that in just one second. So once you have designed the class, done the thought work, you've started stubbing it out, you can make the JavaDoc to make sure it compiles okay and it's all clean. A little word about what that JavaDoc can entail. We have talked about how it needs to have one of three. There are three kinds of commenting methods in Java, and one of them is the double slashes, like we just saw in the to-dos. Another one is a slash star star slash, a little bit like the second bullet point here, but instead of putting 2 stars, you put 1 star. And then if you put 2 stars like this, that indicates that it is a JavaDoc comment. And what that means is that when you run JavaDoc, JavaDoc the program, will look for those comments. And when you have those comments, it's going to try and process those comments in a special way. Well, what is the special way? Well, there's this particular markup that can be put into those kinds of comments that will be read. So markup is like HTML. If you've ever used HTML, or if you've ever edited a Wikipedia entry, there's all kinds of different kinds of markup that are used to add formatting to text. JavaDoc is no different. It has a kind of markup that's special to code, Java code. So just as a principle, if you're going to bother doing this, what you should do is you should make sure that every class and every method has a JavaDoc comment, and that comment should specify what the purpose of the class is and what the purpose of the method is. So when you guys turn stuff into me, I would like you to do that. I would like you to have JavaDoc comments for each one of the classes and methods. And that doesn't preclude having other comments in the body of your implementation as well, but those are not going to be JavaDoc. Those are going to be 2 slashes, maybe describing what your loop is trying to do or describing what a particularly inscrutable bit of code is the intention of it. 2 of the kinds of syntax that are common in JavaDoc are the @param and @return keywords. And if you are in front of, if you're editing and you're in the code and you start a JavaDoc comment by doing /** and hit enter, Eclipse is smart enough to go ahead and fill out a template for your JavaDoc comment by looking at the header of either the class or the method that's right below the comment that you're starting, and it'll throw up a param and a return as appropriate. Not surprisingly, the param syntax is used for describing parameters that are being passed into your methods. So you should add the name of the argument and an explanation for what it is. So if it's like a deposit method for our bank account, you'd say something like the amount of dollars to be added to a bank account. And maybe there's a name for it, deposit amount. The return keyword is used to describe what's being returned from the method. And you're not going to have it if the method only has side effects. If its return type is void, you won't have any return syntax. If it has side effects, though, you're going to specify that in the comments above these param and return. But if it's not returning anything, you don't need anything specific there. The kinds of things that are real common to include in the return and the parameters are things like what units are you expecting. If it's something that is a number, in Java, we have these double types, we have integer types, but that doesn't say anything about what the units are. So maybe you're asking someone to submit a link for a currency, and you should probably specify, well, is that US dollars, or is it Mexican pesos, or is it yen, or what is it? Euro? And likewise, is it meters, miles, feet? Are you in the modern world and using the metric system, or are you stuck in history and using English units? Side note, if I was ever going to be president, the one platform that I would have would be switching to the metric. That's the only thing I would care about. And that's a good indicator of why I should not. What's that? All right, great. I got 1 vote. Yeah, I think it would be pretty successful if I was able to just get that accomplished. Yeah, it's sort of like, set your expectations low and they're easy to meet. Actually, I think that would be very, very difficult. But, it'd be one thing accomplished. What was this class about again? Oh, yeah, programming. Okay, good. Great. So JavaDoc has a lot more syntax than just param and return. There's all kinds of other sorts of things that you can have on there, and if you want to look at them all, you can look at Oracle's website. In particular, if you Google for how to write doc comments for the JavaDoc tool, that should bring up a page that drops you into all of the documentation for JavaDoc along the way. And the link is right there below. Better at copying URLs and typing. And of course, for simple classes, you don't need many other code, but you can do things like link to other methods and link to other classes from within your code. You can have version numbers and all kinds of other stuff written. Pretty powerful. Great if you're going to have your class consumed by other. So, it's worth reiterating that what JavaDoc is doing is it's creating a document, a formatted version of the public interface of your class. So the public interface is that interface, that way in which an application programmer is supposed to use your class. So those aspects of a class through which an application programmer can interact with an instance of the class. The implementation is not visible. So those things that we actually put to-do tags on, that's not actually visible to our programmers, and it shouldn't be because of the idea of abstraction and encapsulation. The idea of abstraction says, well, we're giving you a bank account, and we actually don't want to tell you the details of how we're going about doing it because that's not of concern to you. And furthermore, it might be the case that in the future at some point, I would like to change that, and I don't want to have to change my public interface if I decide to change my implementation. And so all this it can be done without implementation. So as you're doing that, you might find that the words public and private are now being used in a way that reflect that implementation or the usage parameters. So we've seen public and we've seen private used before. In this little chunk of code, we used public to describe the class itself, public class bank account. And that meant that this is a class that people outside of our file are allowed to instantiate. And so within that, though, we had a public instance variable called balance. And that was how we were going to internally keep track of the balance in the bank account. And it was private because we didn't want people who instantiated our class to ask for that balance directly. We wanted them to ask for the balance through a method called getBalance, which isn't shown here. And that's because at some point in the future, we might like to change the way it's implemented. Maybe rather than keeping track of one double, we would like to explicitly keep track of dollars and cents separately so that we make sure we don't get any rounding errors. Rounding errors in bank account classes are like the total plot element, some surprising number of. Have you ever seen Office Space? I've never seen Office Space. Office Space is great. I'm not sure that I would say the entire plot hangs on a rounding error in bank accounts, but certainly an important plot element is one of the programmers in that movie discovers that he can take all the rounding errors and move them over to his bank account. So make like fractions of a penny a day by rounding down instead of rounding up. And the programmer activates it, and within a few hours, he has billions of dollars in his bank account and starts freaking out because it was way, way more successful than he thought. So all that is to say is that if you wanted to change your implementation so that you weren't relying on Java's rounding functions, you were actually explicitly being careful about dollars and cents. You might end up having a separate instance variable that's dollars and integers, and a separate instance variable that's cents, integer representing cents. And if they were private and the only way to get the balance was through a public getBalance method, well, that would be okay because your implementation just has to maintain consistency with the public interface, with the documentation that you provide. And if you can do that with some other implementation that's more accurate or more efficient, then great, go for it. In contrast, the constructor here is public. We would like people to be able to create instances of our bank account when they're using them. So that's a public method as well. So the rest, almost all of the rest of the methods in the code that we saw previously in this slide deck were all public. But there's no reason why you couldn't have a private method as well. Some bit of code that's within your class that's just supposed to be used by the class itself in order to do housekeeping or some sort of computation. But that was supposed to be helpful for you as an implementation programmer, but isn't something that's supposed to be exposed to the rest of the users of this class. So for, what would be something that might be a private method in a bank account, maybe it would be some kind of a rounding function where you check to make sure if the rounding was being done correctly. Well, you don't want the rest of the world to do that. You just want the rest of the world to know their balance and you want it to work. Maybe that would be something. Okay, so I mentioned test-driven development. If what you've done is created this kind of a stubbed out class and you are doing test-driven development, what that would entail would be writing your tests before you actually implement your class. Now, that's kind of crazy. So over here on the right are some examples of tests that are in the class. And you can see that because the tests only rely on the public interface of our class, we could write this test and we could have it compile without any problems, even though we haven't implemented anything. But it wouldn't pass the test, right? It's not going to pass the test until you implement it. But what you do in the process of writing a test before you implement the class is you really cement what it is you're about to implement. You really make it clear what is the behavior of this class. So if you look at the test number 2 here, you can see that we're creating one account, which is has a variable. The variable Bob is a reference to one bank account. We deposit $100 in it. We have Jill, that's a reference to a second bank account, 2 instances of bank account objects that have different instance variables within them. We come up with a transfer amount, and we withdraw that amount from Jill's account. We deposit the same amount to Bob's account, and then we verify that the amounts have gone up and gone down by the appropriate amount. Now, if we run this test, it's going to fail. The constructor will work okay, but the deposit will work okay because it doesn't actually return anything. We're not doing any tests. The only place where there are tests are where those assert equals are present. And the assert equals are the only place that we're going to fail. They're the only place that could fail because that's where we're actually testing the behavior of our classes. So in test-driven development, you do the design, you do the stubbing out, you write a bunch of tests, and then when everyone on your team or you, if you're working by yourself, are happy with the way what you've created, you then go into the code and you start writing the code. And as you're writing the code, you can just run the tests occasionally, and you can see how you're doing, because your tests will do better and better and better as you do more and more implementation. And then if you're using code coverage as well, you could then go back and see, well, maybe there's some tests I didn't actually test all my code, and I need to add some. Yeah, Lisa. So assert equals is a method that is, so the question was, what does assert equals do? Does it return true or what? Assert equals is part of the JUnit framework, and it's coupled with that framework. And so when you run the program using run as a JUnit test, it's waiting to see how those assert equals turn out. If they fail, the JUnit framework is going to see that. It's actually going to see it because it raises an exception. But the JUnit framework knows how to process those and then give you that nice green or red layout. So assert equals is like it's just a statement that you as a programmer write. It says, hey, if everything's working okay, then I need to assert that these two things are equal, or assert that something is true. And so it's not that you're looking for an effect. You're not looking for a side effect or a return value from the assert equals method. It's more that you're writing this because the JUnit framework is going to make sure that that passes. If it doesn't, then you get a lot of, although you're not really good at reading it yet because you haven't had a lot of experience, the JUnit framework will give you a lot of user interface elements that'll point you to the place where the reason why you call it is to. Why do you have to specify a degree of difference? You mean the epsilon? You only have to do that with floating point numbers or doubles. And you have to do that because the precision of doubles is limited. So for example, if you do math.square, here, let me, and I don't have a blank, so let's see if I can throw some blank. Here, I'll see if I can draw it. Okay, so if you do something like, scribble on your slides. If you do math square root, you know what, this would be faster. Hi, control room. All right, and let me just make a new class so I can. All right, so here is a class that's just being used for the purposes of testing. Here we run it okay. So that ran hello world, that wasn't the point. But if we say double x equals math.square root 2, we can print that out. And that, get an estimate what the square root of 2 is, and then that. Now, if math was consistent, and we took the square root of 2, and then we multiplied the square root of 2 times itself, we should get 2 back. But there, we're demonstrating that we're not getting 2 back. We're getting 2.0000000. Do you see what's happening there, what the problem is? What do you mean at some point? Yeah, so like when we calculated square root of 2, some of the precision was necessarily cut off. You can think of it as cutting off some of the precision. Another way to think of it is we're trying to represent a floating point number with zeros and ones. And just like trying to represent 1 divided by 3 in decimal is not possible, because you would represent 1 divided by 3 should be 0.3 repeating forever. But in decimal, the best you can do is write 0.33333 until you run out of ink. But it's still not, it's not exact, right? Because to get it exact, you would need more 3s. You need 3s forever. So you have the same problem when you represent floating point numbers with binary floating point. It's just that it's not we don't actually represent numbers in decimal notation underneath the hood. We represent them in a floating point binary format, but the floating point binary format has the same problem. It can't represent rational numbers, all rational numbers precisely. So the square root of 2 is one of those that it can't represent precisely. So it gets as close as it can, but the result is you do it at a computation like this, take the square root of 2, multiply that times itself, you would expect to get back 2, but in fact you don't. And so what you would do here is you would say something along the lines of if x, okay, what you do is you say if math dot absolute value of x times x, value of x times x, what we had, what are we trying to add y, say y equals x times x. Run that. All right, so the question is, are x and y equal? X and y should be equal. We intend for them to be equal. They aren't equal. And so what we have to do is, if we want to say if they're equal, instead of saying if x equals y, because that's going to be wrong. So this reads x and y are not equal, because if we compare x and y, well, they're not equal. It's 1.414 and 2.004. Sorry, it wouldn't be, sorry. Of course it's not equal. That's what we, no. Like this to be. Right, so on line 11 is where we have the problem. If we were doing a test, we would expect 2 and y to be equal, or we would want 2 and y to be equal. We would say it passes the test if 2 and y are equal, but we can't do that, so we have to do something slightly different. We have to say if the absolute value of 2 minus y less than some small number, then they're considered equal. So we're saying the number that I expect it to be, 2, and the number that it actually is, y. If you subtract one from the other, they're not going to be exactly the same, so there's going to be a small difference between them. It's either going to be positive or negative, depending on whether y is higher than or lower than 2, but it's going to be very close. And if that difference is less than a very small number that we set beforehand, epsilon, then we want to consider them as being. And so now when we do run, we see x and y are equal, because the way we're testing it is more sophisticated. And so when we go back to our example here, what this is doing for us, what this code is doing for us right here is that comparison that I just wrote. So it has the expected value, the actual value, and an epsilon. And by putting them in 3 parameters, the code itself is actually doing that comparison that we just talked about. Is there a library that doesn't lose precision in that way? There are, and in fact, there's an implementation that is available in our textbook that shows you how to do that. No, that's in the Python. In the Python book, there's an implementation of that. It's a rational number class that keeps infinite precision by keeping track of the numerator and the denominator separately, never actually doing the division between the numerator and the denominator. So that keeps track of it precisely. It's not as efficient because deeply baked into the chips of our computers are the ability to do floating point calculations in the silicon. So it's very, very fast at doing these imprecise floating point calculations. To do absolutely precise floating point calculations, you can do that. You can write your own class to do it, but you lose some of the speed. The question was originally, like, why are we doing this approximate equality? So it's because of this precision error in doubles. If you're comparing integers, you don't do that. If you're comparing integers, you just have the expected value and the actual value because you don't have that kind of problem. You don't have that kind of problem with strings. You don't have that kind of problem with Booleans. So that's the rationale. All right, so let's work through this idea about design that we're talking about. So let's say if we would like to add the ability to add interest to the bank account design, so interest in the sense of you've kept your money in the bank a certain amount of time, you've earned some interest based on how much you have there. The question we have is how should it work, and how should we stub it out? How should we make that happen? And so what I would like to do is I would like to take a second and let people at home or remotely, not necessarily, think about let's go through the design process of thinking about what methods would you want to add or what methods would you want to change, any instance variables that you would want to add or change, and then go ahead and go through the process of stubbing it out and then adding tests to our bank account class along the way. So let's see. What I'm going to do is I'm going to pause our audio from the stream, and then here locally we're going to do it together. Remotely, you guys can do it on your own. And then once we've decided on a design, we'll come back together and work through the design. Okay, so I'm going to pause so we can talk locally. We'll be back in 5 minutes. Okay, we worked through it here in class, and we decided a couple of the things that we didn't have available to us is we didn't have the interest rate available to us. And so we were trying to figure out how it was that we wanted to handle that. And we also were having we had to work through the issue of the balance. We know that we had to take the interest rate and multiply it times our balance in order to get the amount of interest that was added. We had to work through the fact that that balance is actually contained within our object itself. So we didn't need that as a so let's go ahead and stub out what we came out with here, when I'm working with, and clean it up here for a second. Problem. I was editing stuff on the fly, so let me just see if we ignore this. Don't pay no attention to the man behind the curtain. Okay, so here's our stubbed out bank account class, and what we said is we would like to add something to add interest. And so here in class, what we said is we said we would like to create a method that's going to be called add interest. Our business and econ major in the room recognized that there are some questions we had to have answered about that. Put our in there. One question was, what was the interest? And we decided that the way that we were going to do this is we were going to pass the interest in as a parameter, interest rate. And the other question that we had to answer was, well, interest compounded over what period of time? And so we decided for simplicity that we would just make this an annual interest rate. Other options could have been to have a parameter which said something like, compounding rate, maybe. Could have done that. We decided we weren't going to do that. The other thing we could have done is we could have said, no, we're not going to pass in the interest rate as part of this method, but we'll have the interest rate be part of the constructor. And we'll store the interest rate as part of the object itself. But locally here, we decided, no, that's not how we were going to do our design. We're going to do our design like that. So we know that we talked about the side effect of this class, the side effect of this method, The side effect of this method was that it was going to increase our balance by as if 1 year had passed with this interest rate. And then we also had to talk about what the return value was. And we said that, well, given that we're going to be returning anyway, and we're also going to be calculating it, that we would return the amount of interest that was calculated, that was added to our bank account. So we'll just say we're returning a double as well. Public. Can't do that. All right, so to make the stubbed out version pass, I'm going to go ahead and just have it return 0. Okay, so that's good so far for just the specification. Now what we would do is we would add our JavaDoc comment to it, double stars and then return. I get all this good content here. And I'll put a method comment in here and said that says this method will add 1 year's worth of interest based on the balance and the interest rate provided. And interest rate, I'll say the annual interest rate in where 5% should be passed 0.05. So just clarify that if you want a 5% interest rate, the way you do that is you pass in 0.05 as opposed to passing in 5. Either one of those would be okay, but we have to know which one you're doing so we don't give you 500% interest or 0.0005. And then the return value will be the amount of interest added. Does that seem okay? This method will add 1 year's worth of interest based on the balance and the interest rate provided. Capitalization issue there. Interest rate, I actually don't need a comma because JavaDoc clear that. All right, and now if I go and I generate the JavaDoc now for my project, I think everything is still set up okay. And I go over to my index.html and I look at my bank account.class. Somewhere down the bottom should be the new did it work? Not work. Try that again. Be a little bit more careful about my wizard. All right, so here's my bank account class, and what I want. Protected. Use my chocolate. Not sure. Constructors. Here's our methods. Any idea what I missed? Huh. Well, that's not very compelling at all. I'm going to try just deleting this whole folder in case it's not overwriting. The teaching moment. Generate JavaDoc, and we're in the bank account project. We're in the source in this package, and I want bank account.java. Even though I have one called bank account.stub, that's not the one I'm working with here. Open it up in the browser when we're done. There we go. So for whatever reason, it didn't overwrite it. So here's now our content. This is our method that we added. We have the public interface has now been extended to add interest. And the other thing that I said is that if we're doing test-driven development, we should be able to test this out. So let's go ahead and create a new test. Well, test interest. We'll create Bob's account 100. It starts with $100, and we're going to assert. Let's see, what do we want to do? Let's say, let's do, what's the interest rate that we like? We like 20%. We don't get 20% often, but we'll go ahead and like it. All right, so 0.2 would be how we would represent that interest rate. And so we know that add interest is going to return the amount of interest that was generated, and 20% of 100 compounded over a year is going to be 20. So that better come out to be true. And then the other thing that should be true at the end of this is that our balance should have ended up being 120. Right? Of course, now if we run this as a JUnit test, it's going to fail because we didn't implement anything. Run it as a JUnit test. But you can see that the test itself compiles. And that's great because it means that we've done our design well, and now we just have to go through and we have to implement out all the work. So do you see that flow? The design process, how you can do all this work without ever actually doing the implementation. So all this work that had nothing to do with programming. I think that's a really important point. All this computer science work that involved no programming, and really important computer science work that had no programming. I think that's something that gets lost a lot when people talk about computing and computer science, is everyone thinks it's about generating the code, it's about making code all the time. And in fact, I think a huge part of it is design, but it's abstract design. To remember as you get stuck in the weeds of some problem set. Okay, so that was the design process. Let's take a look at debugging in Eclipse. Given that we're at a good breaking point, what I want to do is I want to step through the process of debugging, because this is a skill that you need in order to figure out if things are broken. And so we'll take a 5-minute break. We'll come back at 11:27, and I'll show you some of the mechanical ways of doing debugging. And in the intermediate time, I'm going to fill out the bank account class, and I'm going to introduce an error in it, and we'll go through the process of trying to debug that together. Okay? All right, so 5-minute break. See you in a moment, and great. Okay, we're coming back, and what we've got here is we have got the code for the bank account that I filled out, but what we want to do is we want to debug it. And so the first thing that I'm going to do is share it with a few people in the audience here. Maybe I better go online first. All right, once I see that the projects have been successfully synchronized, down at the bottom, I'm just going to break the connections so that you guys have a copy of the code to work from. Looks like everyone has a copy. By that. If anyone else needs it, you can share it from each other. All right, so now the issue at hand here, what we're trying to tackle is we're trying to tackle debugging in Eclipse. So now Eclipse has a really powerful debugger. Most IDEs have a debugger of some sort. Certainly Xcode does, Visual Studio does as well. Actually, one of the strengths of Visual Studio is its debugger. It's really, really strong. Eclipse has one that's good as well. And what happens when you debug in Eclipse is that you take a running program and you pause it at different points and you look at the state of the program at a given moment. And that's really helpful if you have a bug because you can walk through line by line and make sure that your intentions of the logic of the program are actually being executed the way faithfully to what you wanted it. So to do that, we're going to put a breakpoint in, and we're going to, when you run a program, it's going to bring up a different, let's see, language that Eclipse uses as a different perspective, actually, I think. I can't remember, perspective and view, one of the two. And that's going to rearrange the layout of the panes in your screen, and it's going to give you a little bit better layout for working with a running program. So then we'll look at placing breakpoints, stepping over into, out of, and running to different points, and then how we can use watch statements to help us out. So going back to Eclipse, the first thing we need to do is we need to say, okay, well, what is it we're trying to debug? And so we have a test class here. I'm going to break this out on the right. And I'm going to run this test class as a JUnit test. And let's see, run it as a JUnit test. We can see that test 1, test with just test by itself, test 2, test 3, and test 4 all ran okay. I like to use code coverage. I didn't use it in that case. Let me try that again. I'm going to do code coverage as a JUnit test. There we go. And there, so we can see which code got run. We can see that test, looking here, we can see that test ran, test 2 ran, test 3 ran, and test 4 ran. As I scroll down my bank account test, I can see that those lines are green, indicating that the code was run. And because our assert equals lines didn't were met, because those assertions were met, we were able to pass through them, and those tests passed. And then finally, when we got down to test interest, we see that that test didn't pass by looking over here on the left side under JUnit. And we can see additionally that this line of code didn't get run here. And since 55 didn't get run, it's the case that the error was in 54. Down here under my JUnit testing pane, I can see the stack frames of what the state of the program was when it crashed. And if I click on the top one, I can see the basic error. It says that I expected 120, but it actually was 100. Huh. So when I added interest, 20% interest to my bank account, I didn't get $120 when my balance was 100. Something went wrong with that code. So that's what we're going to debug. And if you click on the second line in our JUnit test here, it'll take you to the line where it actually crashed. And so, oh no, actually it crashed on 55, not 54. So Eclipse indicated that 55 didn't successfully run. The error did occur on 55, but in order to figure that out, I had to double click on my JUnit. Okay, well, I'm not sure quite what's happening here, but what I would like to do is I would like to use the debugger to try and understand what's happening. And so I'm going to place a breakpoint in my test code on line 52 by clicking next to 52, double-clicking, and it gives me a little blue dot. That's a breakpoint. And on the scroll bar over there on the right, you can see the little blue square showed up as well, indicating that there are breakpoints. Now what I'm going to do is I'm going to go back to my package explorer. I'm going to go back to my bank account test, and this time instead of doing coverage as, I'm going to debug it as. And it's a JUnit test, so I'll debug it as a JUnit test. What I expect to have happen is that the first 4 tests will run, and then my program is going to pause in the middle of running the test interest test. First thing that happens is I get a window from Eclipse asking me if I want to switch perspectives, switching perspective to the debug perspective. And I do want to do that because that's a better view for this case. And you can see that all my windows have been realigned. Oh no, what if I want to go back to where I was? I got lost in the layout. Up here on the right is where you select those different perspectives. So if I click here, I'll go back to my normal Java. If I can click here and I go to debug, even if I'm not debugging. So what's different about the debug pane? Well, a couple things is that up here in the upper left, by default, you see all the programs that are running. So it's possible in Eclipse to have multiple programs running at one time. And if that's the case, you'll see several entries that have a top level like this. What I'm looking at here is I'm seeing that I have a top level bank account test being run. Here you can see that it's being run. It says this remote test runner line, and that's a clue that I'm running it under a JUnit test framework. I'm in the debug mode, and so I actually have this thread has a pause symbol on it. A thread is one particular movement of execution, one control flow of execution through your program. Most of the programs that we're going to write are going to be single-threaded, but it's possible to have a parallel program where multiple things are happening in your code at one time. It's called multi-threaded programming or parallel programming. We only have one thread. Well, we have one. Basically, we have one. If you are not running in debug mode, you can't pause your program. The only way you can pause your program is if you're running in debug mode. If you do coverage as or you do just run as, then your program won't stop at breakpoints. My code has stopped at breakpoints, and if I open up this accordion, I can see the stack frame of all the methods that were called up to the point of my breakpoint. If I double-click here, it'll take me to the code where I'm paused. I double-clicked on that. I'm now at line 52 in bank account test, and that's reflected as well in the stack frame where it says bank account test interest line 52. So I'm in this method, line 52. I'm paused right now. Over on the right, I can see a flow organization of my test, the current focused code, all the components in it. If I click over here, that focus will change, and now I see all the methods associated with the class I'm testing, currently here. Down in the bottom, I see the output of my console. If I were to write any system.out messages, it would be down there, and then different plugins depending on what you've got. So I've got the Saros loaded up. The other thing to notice is up here on the upper right, this is an important thing to notice, is that you've got a bunch of variables. All the variables that are known at this moment are currently listed here. So there's this object that's associated with the actual bank account test object that I'm working with. I can expand that if I want to, but there's nothing of interest for me right now there. I also can see a listing of all my breakpoints. Right now I have a leftover breakpoint previous project, so I can remove that one. And now I only have one breakpoint, that's the one that I'm currently stopped at line 52, and you can see that line 52 is listed right there. If I wanted to temporarily make that not active, I could uncheck that without actually making it go away. It just wouldn't be active right now, but I'll keep it as an active. I want to add one more view here. I want to add an expressions view, so I'm going to go under Window, Show View, and Expressions. And that'll let me write arbitrary code that I might be interested in evaluating with all the variables that are currently known about at this moment in code. We're going to let that sit for a second. And line 52 is highlighted, and that means that this line of code will be the next line of code that will be run. And so I'm going to choose one of these buttons up here. I can hover over it to remind myself what it is. Either I'm going to step over this function and proceed to line 54, or I'm going to step into this function and look at the code for the constructor for bank account filled out, or I can step out of this code, and what that means is I'm going to immediately go up the stack frame to whatever method called test interest, which is not helpful because it's the code that's running right now. Okay, so actually what we'll do first is we'll step into this code, and we'll step into that code so that we can see the focus of the control flow move into the constructor of bank account filled out. I'm going to step into that. Do it. Into it. First we're going into a process of creating a double. So I'm going to step out of that. This is the argument that's going in. Step over, step out of that. I'll step over it. Okay, now I'm back to where I was. I'm going to step into this line again. That first line was creating the 100 for me. I'm going to step into this code again. Now you can see my focus has shifted over to line 23, and if I needed to find it, I would be right here. Now you can see I was at line 52, and now I've called line 23, and I'm now in line 23, waiting to return to line 52. As I look over here, I'm on 23, and if I look at variables, you can see that the balance parameter that's being passed into this method is instantiated now, and you can see that the value of it is currently 100. Okay, so that's good. That's what I expected. I expected to create this bank account balance with 100 as the initialization. So I'm going to step over line 23 on the left. Now I'm about to set this.balance equal to balance. Well, if I look up here, I have a this variable, and the this variable shows me all the instance variables associated with the object that my code is currently in. My code execution is currently within the bank account filled out class, and so this is referring to the current bank account filled out object that I'm in. The balance is currently 0. If I step over line 24, you can see that this highlights to yellow, indicating that the value changed. It's now 100 because I just moved the value of my parameter variable into my instance variable with line 24. And I'm now on line 25, ready to return from my constructor. So I will step over this, and now I'm back on line 52 on the right. You can see I lost one line here on my stack frames. I'm back here. We have completed the new command. We haven't assigned it to the variable Bob yet. So as I step over this line, the value that was returned from the constructor, or the new object reference, which is what a constructor returns, will be assigned to the Bob variable. And you can see that up here in my variables, I now have a Bob, and his balance is 100. So I successfully created that object. I'm now on line 54. And if I go over to expressions and I want to run some code, I can do something like call bob.getBalance and see what that returns. And you can see that that would return a 100 if it was run at this moment. I could call anything that I wanted to at this point, and it's like a little playground to just check out some of the different valuations of expressions. It will continue to update. Every time I step over the code, these expressions will continue to update, so that if I wanted to, I could just watch to see what bob.getBalance returns. Now, notably, this is actually calling getBalance. So it's returning what getBalance returns, as opposed to looking at the variables and actually looking in Bob and seeing what the balance is. So the expressions is showing me what the method returns. The variable is showing me what the variable is. Okay, now I'm on line 54. I'm very interested in what add interest is going to do. And so let's try stepping into that code. The first thing that happens is I'm creating that 20, so I'm going to step over that. Now I'm going to try stepping into it again. Now I'm in my add interest method over on the left, line 69. And everything looks good. I'm multiplying the interest rate times my balance, and I'm returning it. That seems okay, right? Isn't that what I intended to do? Seems okay to me. So I'm going to step. Oh, I'm being called out. What's wrong? Okay, so you're saying I have to multiply the interest rate times 1 plus the interest rate times the balance. But isn't what I'm returning the amount of interest added? And you're on to something. Right, it's not connecting with adding the interest rate to the balance. It's successfully calculating the amount that should be added, but nowhere is the balance actually changing. Right? We're not assigning the balance anything new. Okay, so good. So you identified that in the process of stepping through here, something is not going wrong, not going right. So even though we're in the middle of the execution of the code, I'm going to go ahead and try and edit this. So we said that, well, we said this is the amount of interest that we're adding. So that's okay. So much. We'll say double is going to the interest is going to equal that much. Get to see all that code. But now you said we needed to update the balance. So what is the balance going to be now? Good. All right, now we're getting an error because we're not returning anything. What do we want to return? Okay, when I saved that, Eclipse is trying to trying to change the code on the fly, actually. So it may or may not incorporate that code and how that works. So there's my interest. Oh, look, it did it on the fly. Pretty good. So we're in the middle of a running program, and Eclipse was able to change the code while we're running. It's kind of amazing. Doesn't always work, depending on the sophistication of the changes that you make. But we just made a new interest variable. Its value is 20. That looks good. And now we're going to step over this next line. We said the balance now got updated. Let's check that out. Balance is 120. That looks good. Now we're going to return the interest. Step over that line. Now, actually, we're going to pass that no problem. Because now as we step into getting the balance, we can see this dot balance equals 120 because we edited the code. So I'm pretty comfortable with this. So rather than stepping over using these buttons, I'm going to go ahead and hit the run button. That's just going to continue running until it hits another breakpoint. All right, well, how did that do? What happened there? Well, let's go back to our Java view. And it looks like, oh, now after those changes that we made, we just passed all our JUnit tests. So let's go back and let's just run it clean because we made some edits along the way. So we'll try and do coverage again as a JUnit test. Now we're running everything. All right, so doing test-driven development, we were able to describe what our expectations were. Our code didn't meet our expectations. And so we went through the debugging process of adding a breakpoint, stepping through the code to try and figure out, okay, somewhere in here we were moving too fast, we've had a typo, we made a bug, and then we were able to identify how we can fix it. And Eclipse was actually, or Java, Eclipse and Java were able to fix it on the fly. The one thing that I didn't show you was the run to command. I'd like to show you that now before we go back. So what I'm going to do is I'm going to debug this code again. And I'm going to do that by down here and doing debug as a JUnit test. It's going to break on the same point, line 52. It's going to ask me if I want to shift to my debug view. Double click here to go to where it's paused. I'm on line 52. I'm in my test. I'm just about to create my new instance of a bank account object. And I know that my problem is somewhere down here in my add interest. And maybe I don't want to step through every single line until I get there. I mean, my breakpoint was okay. It's on line 52. But maybe I'm actively debugging. I'm running it again and again. I just want to have it continue running until it gets to a particular point. Well, I can come here and put my cursor on line 70. Maybe that's where I want it to stop. And I can actually say, where is it? Run to line right here. Or you can see the hotkey is Command R. So I'm just going to remember that hotkey. I put my cursor here and I hit Command R, and the execution will continue until it gets to that line where my cursor is. It's a really nice shortcut for doing debugging because what you can do is put a breakpoint somewhere nearby where you want it to be, and then rather than having to hit step over, step into, step over, step into over and over again, you can jump through the code hitting Command R and moving your cursor around so that you can see what's happening. So now as I look here, I can see that all my variables have been updated, and I can see, okay, what's the state of my code right now. I present this to you because students, for whatever reason, are really resistant to using the debug tools of their IDEs in order to fix their problem. I don't know why. I don't know what it is. It's something about the complexity of it, or it feels maybe like you have to slow down too much, because it does cause you to slow down and have to step through a little bit pedantically what your code is doing. But it's kind of like you can just keep changing your code randomly and trying different stuff, which is like guessing in a lot of ways. Or you can put a breakpoint in and try and walk through your code very carefully and make the code do the right thing. And the latter takes more investment and time rather than just changing something and trying it, but it often produces much solider code. And it also helps you to understand a little bit better what's happening. So it builds understanding as well as helping you to. A lot of times you realize that your mental model of a variable or of Java or the way the function calls are working wasn't quite right. And that gets revealed as you step through it. Okay, so all that is an argument that debugging is really important. So what I showed you then is I showed you how to place a breakpoint. That's double clicking on the line that you want to break it on. I showed you how to run in debug mode. So debug as a JUnit test, or you can debug as a Java application as well if you're not running in a test mode. I showed you that you can step over or step into different method calls. That's whether or not you want to follow the execution deeper or you just want to step over a line. I didn't really show you stepping out of very well, but stepping out of is when you move back up. If you accidentally step into something you didn't mean to, you can step out of and go back to where the call was made. Showed you run to, where you place the cursor and then you hit Command R and that'll jump you to the code. And then the watch statements are the statements where you can look at the variable values or write expressions. Debugging, awesome. Tests, awesome. Love them. Any questions about that? Any questions from Slack out there, Slack world? So the next sequence of things I'd like to touch base on are just some of the details of things that we've glossed over. Again, want to fill out some of the bits a little bit. The first one is to talk about local variables. So local variables are those variables that are declared within the scope of a method or curly bracket. So I'm using a couple words here. Local variables, so those are variables that have small local impact as opposed to a global impact in your code. I'm using the word scope, and scope is a word that we use to say, where is this variable known? Where can you use this variable? And in which scope can you use this variable? It's like putting fences around your code a little bit, saying within these fences, you can use this variable. And typically, for local variables, the scope of the local variables is within the body of a method. Although technically, the scope can be a little bit more constrained. Technically, the scope can also be within curly brackets. You can introduce all kinds of curly brackets everywhere in Java if you want, as long as they're paired. They don't have to be after a method statement. You can just put them anywhere you want to create a scope if you're so inclined to. It's not often done, but you can. And then, let's see. And then, so local variables are known within that scope. Local variables go away. So after a method exits, the local variables are actually removed. So they're only around for a little while. Parameter variables are a lot like local variables. They're only within a small scope. They're also attached to a method. And after the method goes away, the parameter variables go away as well. They don't stick around. And they're declared in the header of the method. So if we look at this slide here, actually the slide is intended to show you these variables. And unfortunately, the code itself is kind of buggy. So I should probably fix this, but this code right here has error in it. Nonetheless, it does an effective job of showing you local variables and parameter variables. So let's see, the local variable is right here. This is the variable new amount. It is of type double. It is a variable that we are declaring and initializing just within this method called deposit. We can use it after we've declared it, but when we return from the deposit method, it's no longer there. We can't access it anywhere else. It is like a temporary variable. It's like setting up something briefly to use it, and then it goes away. Similarly, but not exactly the same, are the parameter variables. The parameter variables are declared as part of the method header, and they're also only available within the body of the method. But unlike the local variables, we didn't have to initialize those. Those were initialized when the method was called. So when the method was called, dollars and cents got initialized to whatever the caller wanted to pass into us. But their scope is only within the method body. As soon as our method is done, they're gone. They're out of scope. So you can see that within this method body, we're using new amount, we're using dollars, we're using cents. We're also using this dot balance. And that isn't parameter value, of course. That is, so we have two parameter values. We have dollars and cents. We could have multiple local variables as well. And then we also have our instance variable. Now contrast our local variables with our instance variables. Our local variables go away when our method is done, but our instance variable does not. Our instance variable sticks around. It sticks around with the lifetime of the object, not the lifetime of the method. Sense? Not an overwhelming show of nodding heads, but okay. Work through it a little bit. The local variables and parameter variables, they belong to methods. They're sort of within the scope of methods. They're only available in that scope in which they're defined. So they're only available within the smallest curly brackets that are outside of them. So you make some curly brackets, you put the variables inside them. They're all only known within those curly brackets and any smaller curly brackets. So if you had, does that make sense? Balance, and then, and they're only available after they're defined. So typically we see them defined at the start of our methods. That isn't required. You could define them anywhere within your method where you wanted to use them, but you can't use them until after they're defined and actually initialized, but certainly can't use them until after they're defined. So you could define a variable down in the middle of your method body, but then you can only use it after it's been defined. So just as part of organization, often people define local variables at the top of their method, but not always. When you return, they're gone. When you leave the curly brackets, their scope is gone. You can't access them anymore. And you have to initialize them yourself. Local variables and parameter variables you don't. Parameter variables come in with an initialization, but local variables. Instance variables, nope. They belong to the object. They're available as soon as the constructor has been called, which is the first method. They're only available within the scope of the object. So any method within an object can use that instance variable. And if it's private, only methods within the object can use that variable. If it's a public instance variable, then people outside the object can use it if they reference it. They remain available only as long as the object is available. So if the object goes away, if we lose track of the object, we just can't get to it anymore. We don't have a reference. Unlike the local variables, instance variables get automatically initialized. Not always to very helpful values, but to either 0 or null if you don't initialize them yourself. But again, our best practice for instance variables is to initialize them in the constructor. That's just, we learned that habit in Python. It's a good habit to have. It makes sure that you're starting with the default value that you intend rather than having the compiler give you a default. The question is, what is null? No, an empty string is not a null value. You're right, though, that 2 quotes with nothing between it is an empty string, but that's actually an object. It's an object with no data in it, but it's not null. Null is what you get if you have a reference that you haven't initialized. So if you create a string variable, string Tim semicolon, Tim is a variable, but it doesn't have any data. It doesn't even have like a little red box of memory allocated. And so it's null, points to null. So if you try and print something that has null, if you try and print it, it's gonna print out null. The bigger problem is if you try and dereference it. So if you try and do something like, let's say you create a bank account, I'll show it to you. If you have a test, for example, or we'll create a new test in which we make this error. Called a null dereference. It's not spelled that way. Okay, so after line 60, we have a variable declared called Tim, and it doesn't point to anything. It points to null. So it points to null. So if we tried to do something now and we said we want to say, for example, assert equals 0.0 tim.getBalance. We're using the dot notation here, tim dot get balance. That means that dot means follow the reference, go to the red box of memory that's been allocated and call the method getBalance. The problem is we haven't allocated any memory for this instance. It's null. And so if we try and do that dot, if we try and execute that dot, we're trying to follow a null pointer, and there's no memory there. We haven't set anything up. And so if we actually run this, we end up getting an exception called a null pointer exception. Null pointer exception, there you go. If you look to see where it happened right there. And it's because we tried to access something that didn't exist. So we declared the variable, we set it equal to null. If we want to fix that, we have to say new bank account. Right now we're calling it bank account filled out because we filled out our stub. Okay, now we created some memory, and we said Tim now points to that memory. And so now if we do that dot, we go to that memory and we call the method that's there. So now we're not going to get that problem at all. Now everything's good because we called that Tim variable. Good. So that was talking about the automatically initialized or default to null. Interestingly, Swift, looking at in another class, Swift is probably one of the more recently created languages that's out there for broad consumption or being forced for broad consumption by Apple. They have recognized that these null pointer dereferences are causing various kinds of security errors and bugs in code because programmers might find themselves with a variable that doesn't have any object allocated to it. So they make these null pointer dereferences accidentally. And so Apple has introduced in Swift a particular kind of syntax called optionals that forces you to deal with null pointer dereferences more aggressively than Java does. I'm not sure if I like it or not. I'm jury's still out on that, but just interesting to see that more recent languages are trying to avoid the problem of null pointer dereferences by changing the language. We'll probably see something like this in Java in the future. Now we don't. Okay. So the scope of these three kinds of variables are different. Local variables have a scope within the curly brackets that contain them. Parameter variables have a scope within methods. Instance variables have scope within an object. The other thing we need to talk about, the local variables, one thing. The other thing is the this reference. We were talking about, now I get into the problem where I can't use the word this for this sequence of slides. So this is like doing improv comedy. You can't say and. You get gonged out. Okay, here we go. The this reference. This is a reserved word that is used in particular context within Java. When you make a call to a method, there are actually two different kinds of parameters that are passed. This was true in Python as well. Python made it a lot more clear with the self parameter. Java has the same thing. Instead of self, we use the word this. So when we call a method on an object, the implicit argument that we call is a reference to the object on whom this method is being called. So if we call tim.getBalance, there is an implicit parameter which is equivalent to Tim that is being passed to the getBalance method. The other arguments are explicit parameters, those parameters that are associated with the method that's being called. Consider, for example, a call to a method on an object whose name is mom's savings. Perhaps it is an instance of a bank account. We call mom's savings.deposit 500. And so in this case, the object reference is mom's savings. It better already be a reference to an object. And we're calling a particular method with one explicit parameter, which is 500. In order to actually add that 500 to the balance of the account, we have to know which account to which the balance should be added. The answer to that is mom's savings. Mom's savings is the account to which the balance should be added. So we need to have mom's savings passed as an implicit parameter, and that's going to end up being the this parameter. The explicit parameter, 500, will be passed just as normal. Right? So this is a keyword which captures the implicit parameter passing. Everything else is an explicit. This is the keyword that references that implicit parameter. So on the, let's see if I go back one, sorry. If I go back one, forward one, okay. Lost a slide. On the bottom right code example there, you can see that we have a deposit method that perhaps is what we were working with mom's savings. And we have a instance variable called balance. We have the parameter variable called how much. And you can see that how much is being added to balance. In the top example, we're going to use the implicit parameter this to make it clear that balance is an instance variable that's attached to the current object on which we're working. In this case, this and mom's savings are referencing the same object. And because this is an implicitly passed parameter, when we call deposit, we can be sure that the correct balance is being updated, the one associated with mom's savings, not with daughter's savings, Tim's savings. In the bottom example, when we referenced balance and we said balance equals balance plus how much, we're referring to the same variable. And the compiler is adding this to balance implicitly, automatically. A lot of times this is used in order to avoid shadowing of local variables with instance variables. So in this code in the upper right, you can see an example of a constructor in which a bank account is being initialized with a particular balance. And we want to save that initial starting point balance in the instance variable's balance. But unfortunately, they're named the same thing. Oh no, horrible mistake. If we just said balance equals balance without adding the this parameter, we wouldn't end up changing our instance variable. We would end up saying that the parameter variable balance equals the parameter variable balance. In order to get around that shadowing, the fact that the parameter variable balance is blocking our access to the instance variable balance, we specifically say this dot balance to reference which balance variable we care about. So this is both helpful just for clarity, but it's also helpful to be able to get around shadowing to disambiguate whether we're talking about the instance variable or the parameter variable. If there's a conflict between an instance variable name and a parameter variable name, or an instance variable name and a local variable name, the local or parameter variable are going to take precedence over the instance variable. If parameter variable and the local variable are the same, I don't think Eclipse will allow you to. Because they're both in the same context, it isn't going to be able to. So I guess there's a question of why would it let you do that? You have an instance variable that's named the same thing. And that part of the reason is because you can use the this keyword to get around it. And part of the reason is because you may not always know if you're inheriting, we haven't talked about it, but if you're making a class that inherits from another class, you may not actually know all of the instance variables that are available to you because they're implemented in the parent class. And so you just may naively be calling something balance and not know that the parent class has some instance variable called balance. And so it's no problem to shadow it because you didn't know there was an instance variable anyway. So I think that's part of the design. Okay. So let's see, that is pretty much everything that we've got for today. So just to summarize, what we were working on today is the second half of chapter 3. We were walking through the process of designing a class, and we looked a little bit more specifically at what that's like, how you go about designing the public interface, about how you can stub out that interface without having to implement it. And by stubbing it out, you have enough that you can write JavaDoc for it. And if you do test-driven development, you can actually write your tests, although you can't pass them, just with the stubs. We did an example of that with our add interest method, and then we went ahead and we wrote it out. We looked at difference between the scoping of local variables and instance variables, and then we ended here with the this reference as well. That kind of wraps up chapter 3 pretty well. There's a little bit more in chapter 3 that focuses on some graphics classes that we're not going to focus on very much. I would rather spend some time working on JMonkey Engine, which is a 3D environment, like a high-resolution Minecraft, kind of. I would say first-person shooter kind of environment, but there's nothing about shooting in it. Programming, I suppose, but it's just a 3D environment. I'd rather spend our time looking at that. We're going to introduce that in the looping, in the chapter on looping, which is chapter 6. The only other thing we need to do before we leave chapter 3 is to talk about JUnit testing in a little bit more detail. But given where we are today in terms of time, I think we're going to pause on that for now, and we'll pick that up beginning of the next class. Any questions before we wrap up? Anything online? Going once, going twice. Great. Thank you for your attention. See you tomorrow.